All right, so these questions are off of the assignments that we did during our Keystone review that involve functions. First few questions are from the classwork there, so this one is number 2. It's a multiple choice question. Which sequence can be represented by this expression? And so what I did is I kind of constructed this table here to pretty much determine which of these was the correct option. And so I wanted to pick my values for n, and with a sequence we always start with n of 1 and work our way forward by 1, and then I was putting that value of n in place of the n in the formula that they've specified for us, and then computing the answer that I should get. So when I do 3 times 1 minus 2, I get 1. When I move on to this n value and I put 2 in place of this n, 3 times 2 minus 2 gives me 4. Move on to 3. 3 times 3 in place of the n is 9. Minus 2 gives me 7. And then I put 4 in as well. And if you look at those options, if you look at the options that we have over here, we know based on what we see down this column right here that we're definitely looking at not what I just highlighted. Should have highlighted that, right? So in the next one that we'll check out here is number 5 from off of the same page. And this one said, what is the range of the relation? Well, you really just had to make sure you recognize what this term means. And if you're dealing with the range of a relation, it's always going to be the y values that are represented on it. So if you look at the y values that are represented here on the axis, we've got y values from -6 to 10, but we don't have points plotted at every single one of those y values. We've got a point plotted here at a y of 9, a point plotted here at a y of 6, we've got a point at a y of 3, a point at a y of, I guess that'd be 0 if we're not moving up or down at all, and then a point at the y of -3. And if you look at the options, we need to pick the option that has all of those y values that we just rattled off, and I think it's pretty obvious that it's going to be choice D. Next one that we'll talk about a little bit here is also another question about range. So again, you have to realize that the range of a relation, the range of a function, that's always going to be the y values that are represented on that graph or within that relation. And so what is the range of the relation that's represented below? Now I've already kind of drawn a little bit on top of the graph that was there, but if you look at the endpoints here, we had an endpoint right here at a y value of 9, and we had an endpoint right here at a y value of 7. We also had a point here in the middle of that line with a y value of 8. So it's tempting to say that the y values that are represented are 7, 8, and 9. But then if you think about it, these points are connected together. And if the points are connected, we don't just have a y value at the points that I've plotted, we have a y value at every point that's on that line in between. So all those decimals that are in between 7 and 9 are also represented. 7.5 is somewhere on the graph as a y value. 8.9 is somewhere on the graph as a y value. So we're looking at choice D. One of the bad things about these multiple choice questions, like we've been talking about in class, is when it's multiple choice, that's good because the answer's on the page, but it's also bad because what if you accidentally thought range meant to do your x values? What x values are on this graph? Well, you've got x values from 2 up until 10, and if you accidentally confuse domain and range, you're going to go with choice C. So yeah, it's multiple choice, but just make sure you're slowing yourself down, doing the right thing when you see a problem like this one. Number 8 from that same page is definitely one of the trickier ones that was on the page, and it's talking about someone who's building a fence. And they tell us that at 10 a.m. that person had 750 feet of fence left to build, but then they continued to build, and by 3 p.m. they were down to only 300 feet remaining to build. And what they tell us is that he's going to keep up the same pace, and we have to figure out what time he's going to finish the fence. And so there's a pretty simple calculation that you can do here to figure out the rate that he's able to build the fence and how much fence did he build when he had 750 feet left until the time that he had 300 feet left. Well, 750 minus 300 is 450, right? So he built 450 feet between 10 a.m. and 3 p.m. Well, how many hours went by between those two times? And the number of hours that went by would have been 5. So the rate that he's building is 450 feet divided by 5 hours, which ends up being 90 feet per hour that he's able to build. Well, if he's able to build the fence at a rate of 90 feet per hour, and we know that he's got 300 feet of fencing left to build, all we have to do is we have to take that 300 feet, divide by the rate that he's able to build the fence, 90. We just figured that out, and we've got our answer of 3.3 hours. Now, if you're not careful, and if I erase what I've crossed out over here, you're going to be looking at these options and maybe thinking that choice B is the answer, right? 3.3, 330, kind of similar to each other. But if he has 300 feet left to build at 3 p.m., there's no way he's going to finish 30 minutes later. It's going to take him 3.3 hours past that time to finish. So then the only other thing that you have to try to figure out is whether or not 0.3 of an hour is 20 minutes past 6 o'clock or 30 minutes past 6 o'clock. 3 hours after 3 p.m. is obviously 6 o'clock. 0.5 hours is 30 minutes, right? So 0.3 hours, a third of an hour, is going to end up being 20 minutes. So 6:20 is when he's going to finish that fence. And then on the homework for the same idea from Module 2, the functions day, number 1 said which relation is not a function. Well, if you are using the definition of function, a function is a relation where each x is with exactly one y. And so that's the definition of a function that you've got to use here. And if you look at this first option A, 2 is only with 3, 4 is only with 5, 6 is only with 7, 8 is only with 9. None of the x's are repeated and being matched up with more than one y. Letter A is definitely a function. Now you do have to kind of slow yourself down and realize you're looking for the one that's not, right? So often we're trying to figure out whether it is a function. We see that A is a function. We might accidentally make that our answer, but we're looking for the one that's not. B is a function as well. 1, 2, 3, 4. 4 different x's. None of the x's are matched with more than one y. C is good to go. -4, -3, -2, -1. 4 different x's there. But then check out D. We've got the x of 8 matched up with 6. We've got the x of 8 matched up with 7. The x of 8 is not with exactly one y, and that's why D is the one that's not a function. Number 4 from that assignment is a story problem. What we've said recently about story problems is that sometimes they're difficult because you have to do the setup and then get the answer. This one isn't one that is really all that bad because if you just glance at that first line, what I've boxed up right here is an equation that's already built for us. So we basically can kind of recognize that we're going to have to use what's boxed up on this top line, and that should help us build the answer to the multiple choice question that we actually have to figure out. And so they tell us this is a linear function, and you hopefully recognize y equals 13x minus 7. That's slope-intercept form, right? So we should recognize that 13 is our slope, m, and -7 is our b value, our beginning value for the y-axis. It does go on to say that it represents the amount of money that a fish merchant makes by selling X pounds of salmon. This is pretty important, right? X is going to be a certain number of pounds, and then Y is going to be a certain amount of money. Now think about these options here. If I get rid of what I've crossed out earlier when we were talking about this problem during class, what we have is we have weird options. It doesn't ask us to put anything in place of X and figure out Y or vice versa. It says, which is true? The merchant sells salmon for $13 per pound. Now, what I think is significant about this is that $13 per pound is a rate, right? That's the rate that it seems like he's selling the salmon at. And what we've always said about rates when they pertain to lines is that rate and slope go together, right? So these ideas work with each other, rates and slope, interchangeable, right? So is the slope of this linear function 13? Is the rate that he's charging for the fish $13 per pound? Yeah, it seems to make sense. Now, why can we rule out the rest of these? Well, the merchant sells salmon for $7 per pound. Well, this 7 is a rate right now, $7 per pound. We've never said that B is a rate, right? B is the beginning amount of something. So this is definitely not the slope. We can get rid of that option because of that. The merchant makes $6 for each pound of salmon he sells. Well, I mean, there's a 13 and a -7, but they're not like terms. I can't subtract those and get a 6, right? The 13 has an X attached to it, the 7 doesn't. So that 6, they're just trying to throw a distractor at us there. The merchant makes $7 for each pound of salmon he sells. Well, it might be more tempting to choose that option if this wasn't a -7 If it was a plus 7, we might think, oh yeah, he might make that much every time. But again, this is pretty much a rate, $7 for each pound. So he makes $7 per pound. Well, B is not a rate in a linear function. The only one that's a rate is M. 13 is in place of the M. The merchant's going to be selling the salmon for $13 per pound, and that's why we're going with choice A. And then the second page of that homework assignment has a little constructed response question for you to carry out. They give you this weird bit of information at the beginning here. Relations is described as follows. Each output value, which is just the y, so it basically can say each y is the product of the input value, which is really just x, and 2. So this basically says each y is the product of x and 2. Well, if we just take that statement and basically rewrite it in math, y is, so y equals product, so a multiplication problem, of two things, x and 2. So y is equal to 2x. If you're able to write that out right away based on the information that you can take from that verbal statement, this table is really, really simple to complete. What is going to be the y value that goes with the x of 2? Excuse me, negative 2. Well, if we put negative 2 here, 2 times negative 2 gives us negative 4. We do that same calculation with a new x. We put negative 1 in place of x. Y is equal to 2 times negative 1. Well, that's going to give us negative 2. Do it with 0, do it with 1. You've got your answer. Part B says, is the relation a function? I mean, check out your table. Is each x matched with exactly one y? Yeah, this is only an x one time, one time, one time, one time. Yeah, each x is matched with exactly one y. This is definitely going to end up being a function. There are two more pieces to this. Part C asks us to graph the relation in the coordinate grid, not only for the values in the table, but for all values in the domain that correspond to the points on this grid. So domain would be the x values, right? So we want to show a relation that's graphed for all of the x values that are represented in the coordinate plane here. Now, if we take our points from the table, negative 2, negative 4, negative 1, negative 2, 0, 0, and 1, 2, we don't just want to represent those points on this graph. We want all points to be represented. So whenever we start with a table and we build the graph from it, we plot the points in the coordinate plane, but then we connect them to make sure we include all values of x that we want to show, right? So we end up with that line. And we actually already did part D, write an equation that represents this relation. We did that right away. It kind of helped us throughout the process there. So that's a little bit of help for some of the Module 2 problems that we've done that deal with functions.